Okay, so let's continue with the XML/JSON parser. If you remember, the goal is to parse hierarchical data, whether in XML format or in JSON format. The parser we have is, the syntax is YAML based. It is, the actual operators and everything is our own invention. A bit of a learning curve, but once mastered, is very, very powerful, as Patrick, for example, would probably be able to tell, or Arya. So last time we went through some of the basics, like we said, okay, this is the structure. You have a metric section and has the dash under it. We have tags. The tags need to include the IM name. We have operators like constant, which means a string, or value, which means use the JSON path or the XML path and get the value. Value for JSON and underscore text for XML. What I wanted to go through today are more advanced things like the complex metrics, the transform section, and more advanced operators, okay? Let's start with the complex metric. So if I want to describe a number, I'm going to use the complex metric. So for example, let's say I want to describe CPU. Okay, so the metric name is going to be CPU ID, CPU usage. It's going to have a CPU ID tag like BP0, which is data plane 0 on a Palo Alto. And then the value itself would be something like 71 to represent 71% CPU utilization, right? So a lot of data in the system is numeric data like this, what we call double. And that data can be graphed over time. We can do averages, minimum, maximum, things like that. But what happens when we want to describe something more complicated? For example, we want to describe a static routing table, okay? So this would be static routing table. And then the value itself would actually look like this. It's an array. And in the array, we have multiple lines where we have network, like .1.2.0, subnet, like 24, or subnet mask, and then next hop would be something like 1.1.1.1. Okay, this is how you would describe a static routing table. You have multiple of these, so this cannot be described in a normal double metric. So instead we have the complex metric. That is what this is. The complex metric's value is JSON. Okay, it's always JSON. It doesn't matter if you're generating the metric from the awk parser, from the XML parser, from the JSON parser. Always JSON. Okay. So to generate these guys in the JSON slash what?
I have a question.
Oh yes.
Is there a reason why there's a double quotes on the static routing table IM name and not with CPU usage?
Me being lazy.
Oh, okay.
No problem. We need to generate complex metrics. Now, if we kind of zoom in on the concept of complex metrics, there are two different types. This one is called an array. Okay, it's an array because it has multiple items to it. The array is this, you see this, these brackets, and then inside it, we have multiple, okay? If you write rules, these are called multi-snapshots in the rule base, okay? The other one we can have is just a single value, sorry. What we also call single snapshot in the rule base. And in this case, it would be something like hostname value equals my server. Okay, so let's say we had a metric for the hostname, which we actually do, and the value, the name of the hostname is my server. Okay, it's a string, it's not a number. Notice that this is just a string like this, whereas this is an array. Okay, the way it's actually represented in the back end looks like this. Okay, make sense? Okay. Great. Now the question is, how do we generate this in the XML parser, for example? So let's go into the XML parser. And let's look at, wait, these are the input files. Yeah, we'll use input files too. Where is that? Oh, these are the info files. Sorry. Show admin. This one. Yes. Okay. So ignoring the transform section for a second, we'll remove this just for simplicity's sake. Okay. This is going through the list of admins that we have open, that we have connected to the device, and it generates a complex metric. Okay. So just to show you the input and the output, the input of this thing is an XML that lists all the admins that are logged in. Let me quickly prettify this. It's a bit easier to see. Okay, so you can see there are two admins. There's Indeni, there's an admin. They came from two different IPs. They're connected through two different types. The sessions start two different date timestamps. It's been idle for two different amounts of time. Okay, this is the XML structure we get from the Apollo box. The complex metric we want to return is an array listing all the users. Okay, so this is what we want the metrics value to be. It's an array. You see the square brackets, and it has two entries. This is one. You can see it here. And this is the other. It has three fields. Okay, or if we use the JSON terminology, it's three key value sets. Three key value sets here. This is a key, this is a value. So idle, 0, from 10.10.1.1, username Indeni. Similarly for the admin. That's what we want. This is what we want to send back to the Indeni server, because then a rule can be written on this metric looking for the idle time. Okay, so the way to generate this, actually, I'll leave it open for a second. Stop doing that. Sorry, the Zoom is playing around my screen. How do I get there? Sorry, let me close a bunch of stuff so I can get to the top right of my screen. Well, whenever I'm trying to hover at the top right, it pops up a list of users. Okay, so remember, this is the XML, and we're looking to generate the JSON that I showed you. So what we do here is, it's still metrics like we always have, still the dash like we always have for each metric. The groups function is still there, just like we have with the double metrics, because we're iterating over multiple XML entries. This is one, and this is the other, right? So where the XPath goes all the way down into the entry, like you can see here, okay? Ignore the temp for a moment. We'll get to that later on. We're generating a metric. The tag for IM name is logged in users, because that's the name of the metric we want. And then we say it's a complex metric. Remember that normally, previously we had something that looked value.double. Remember? Had this. Okay, so instead we have value complex. And then we have key value pairs from, and then the value of that, and then username and the value of that. Okay, remember, underscore text is an operator. So what it essentially means is, under the entry, I'm going to look for an element called from, evaluate that, grab the text, and that will be the value of the key from. Okay, so username, admin. Okay, remember, admin is the name of the element, right? Admin is the name of the element. Whereas, which you can see here, whereas username is the name of the key that we want to actually have in the metric, because that's what the rule is going to be looking for. Okay? This last thing here says, oh, by the way, it's a complex array. Okay? It tells the parser, I want to generate an array with multiple lines, each of them for each of the admins that are in the XML. That's how I generate a complex array. Okay, so what's the difference between here and the value and the double ones is that we use complex here instead of double, and then you have sets of keys and values versus in double where you just have the value for the double. Okay, any questions?
So this code here knows to iterate through each and every entry
Mm-hmm.
for admin,
Mm-hmm.
no matter how long that list is,
Right.
and output it into a structured format that
Mhm.
the Indeni server can then read.
Exactly. What we're doing here, we're iterating over the XML content, the entries we have there, converting it into a JSON content that the server can understand and generate rules from. The JSON content we convert it to is consistent for all devices, right? Because it's the target content. That's what the rule can work with. The difference from device to device is how do we generate that JSON structure? If it's from XML output, we're going to use the XML parser. If it's from JSON output, we're going to use the JSON parser. If it's from just textual output, we're going to use just to give you an example for comparison's sake, if we jump into the cross-vendor one, you can see we have it there somewhere. Let me look this up for a sec. Well, this is, yeah, this one. So here's a command from Linux where we're trying to grab who's logged in for how long. This is the awk parser there. I won't go into the awk parser itself, but notice that it's trying to collect the same data and then eventually create the same structure. Username from the terminal thing we ignore. But then it also has the idle at the bottom here. So just the same. It's trying to create the exact same structure as the other one is. The way to do it is different because the output from the device is different, so the parsing is different. But the end result has to be the same for the server to understand. Essentially, our job as IND script writers is to translate whatever output we're getting from the device to something the server understands and is the standard structure. Okay,
Makes sense.
so this is the complex array. It's just like how we'll do that. Let me undo the stuff I'm breaking here, just so I don't actually commit anything. Okay, so we'll look at an example for doing this for non-complex array. Let's see if we have something here that we can use. I think in the config one we had some of that I saw. We have them here. Yeah, we do. Okay, so let me pull that up. In the case of the config, so this happens a lot with a lot of devices we work with. We're going to have one big IND script that parses their main config file and generates a whole bunch of stuff. So you're going to see a lot of examples for complex metrics here. And here is a complex metric that is the simpler version. It's not an array, it's just one value. And what we're doing here is we're grabbing the time zone for the device. So we're saying this is under the metric section. It's a metric. The value is a complex. And in that complex, the value key, its value is what's inside the time zone. Okay? And then we attach the regular IM name tags to it. Again, ignore these. We talked about this last time that we need to ignore these for now, just for simplicity's sake. But this is basically how we generate a complex metric in the parser. Now notice that in this case, it's very, very similar between XML and JSON. So this is XML, what we have here. The difference if we were in JSON is that instead of underscore text, it would be underscore value. And the structure of the path would be a bit different. So it looks something like this, more or less. Something like this, more or less. Probably, I might have gotten something wrong there, but basically this. Okay, makes sense? And then the end result is time zone. How does the time zone look like? If we jump to show running config output, you're gonna see the time zone here somewhere. Here, this is the time zone and this is how the value looks like. Standard, okay? So, those are the complex metrics. Complex metrics are becoming more and more common. Initially, when we started, complex metrics were the less common metric we were generating. They're starting to become more and more common because the rules are starting to get more and more intelligent, and more rules are getting configuration oriented and not just threshold oriented. So that's why we're seeing more and more. Okay, but generally, if you want examples, it's very easy. You can just search through the code, for underscore value.complex, and you can easily see examples of parsing these things. Okay, let me undo that. Now, so that's one part. Another part is I wanted to go through the operators before I go into the transform section. So let's quickly run through the operators. There are not a lot of them, but just so we're familiar with all of them. There's a top level operator called underscore vars. I mentioned this in the last session. It looks like this. It basically lets you define a variable, and that variable is going to be some piece of string, like in this case, part of an XPath. It just makes it a bit easier because then you could put $ curly brackets root instead of this. Just saves you a bit of time. Underscore tags. This will be at the top level if you're writing an interrogation parser. So to give you an example for that, find interrogation, show system info. Oh wait, these are the input outputs. Show system info interrogation. Here, see these guys? These are tags. Remember, this is an earlier point in the training, but devices have tags. So to generate tags for a device in an interrogation script, we use this kind of format. It's still very similar to everything else. Key, value, etc. It's just in an underscore tags instead of underscore metrics. Okay. Underscore metrics we talked about. Each metric must be on its own dash to generate the metrics. One thing that would be important to be aware of, if you try to generate a metric and the path doesn't match anything, the metric will not be generated. Okay, so to give you an example, let's say we're trying to generate this time zone metric. Okay, the parser is going to look for this path and then see that there's a text in there. If this path does not exist, for example, the time zone element does not exist, the system will not generate a metric. It's going to skip it. Okay, that's the behavior. Same thing in the JSON path. If you're pointing in your path to something that does not exist, it will skip the metric. Catches people off guard initially, but then makes a lot of sense once you get used to it. Okay.
Is there any indication that it has skipped over anything?
No, it won't.
It just
yeah, it won't produce anything. That's what it'll do. Okay, so that's the underscore metrics here. At the value level, we talked about value double. We talked about tags and the fact we need to assign tags. We talked about value complex. Now, within these, we've already seen underscore value, like, okay, JSON, that would be over here. In a 5 example, we talked about the underscore value operator that grabs a value from the JSON path, right? It's kind of like underscore text in XML. Underscore constant is also something that we've already seen, like this, where we're saying just use this string as is. A nice little one is underscore count, where you can basically say, hey, I want to count how many entries there are. I don't want the actual content, just want to know how many. Now, over time, we keep adding more and more aggregator functions like this, the ability to do sum and things like that. But it's pretty powerful because it lets you just kind of run certain calculations on the content and use that as the value instead of taking the content all the way back to the server. In the case of XML parser, operators are mostly the same. Underscore tags, underscore vars, all that stuff. The difference is at this level. So it has underscore count, just like the other one. It has underscore constant, just like the other one. It has underscore text, which is like underscore value. But then it also has these three. The underscore count, we mentioned. Oh, sorry, these three. This, attribute, sum, and name. Attribute is a bit of a confusing thing with XML. Let me show you what that means. Imagine that this is my XML content. Class, student, name, John. Okay, imagine that this is the XML content. In the world of XML, you have attributes like, an ID. Okay, this does not exist in JSON, only in XML. It's a feature of XML. People abuse it sometimes. Most XML output we've seen coming from devices do not use attributes, but some do. And sometimes they do it in a very weird way. We have an example with Junos where they use attributes in a very, very specific case, and it actually contains the main value that we need. You can't, in this case, you could do, if you're on the student level, remember, let's say we have groups, which is /class /student, right? Because we want to go over all of them. We can do underscore text to grab the name, right? Oops. You can do underscore text to grab the name, but we can't do underscore text to grab the ID. This will not work because in XML, they differentiate the two. So in order to grab the value of the ID, we need to do underscore attribute ID. Okay, that's the way to grab it. So that is the underscore attribute. Then we have for sum, which is like underscore count, but basically treats it as a number and summarizes them. And then underscore name gives you the name of the element. Again, in some cases, we've seen things like this. So if we go back to our example, it's going to be John Doe, say ID, and then 3802. Okay, so in this case, they actually put the name of the guy as part of the element name. This is not best practice, but some devices will do this. Okay, so the way to get this is groups, class, asterisk. Asterisk means everything under class, colon. And then we're going to do underscore name of, let's say, where's the example here? Just, let's say just underscore name for this one. It basically says I want the name of the element. So in this case, it will give us John Doe. Okay. Now the language we keep adding stuff based on what people need. So if we run into certain things that we can't do for whichever reason, there are things we would add.
Where do you add them?
Well, the engineering team is going to add it to the platform. So we need a request. We need enough requests, and then decide to prioritize it and add it.
Okay.
I imagine those operators are mainly based on like high usage, right?
Yeah.
So you see yourself having to count many things or sum many things.
Yeah.
So having an operator dedicated for that makes it easier.
Exactly. When we see things happening again and again, we say, okay, we'll do that. Okay. Now we get to the slightly more complicated feature within the XML and JSON parser. So a lot of times we have this challenge. Let's say I define a metric that is memory. Okay, so IAM_name equals memory usage. And the value is going to look something like this, right? 71%. Okay. But the data I'm getting from the device is something like this. Data, memory free, kbytes, 1024, not a lot of memory. And then memory used, 712. Okay. But what I need, what the server needs, is the value that is the memory utilization, which is not in this. You can calculate it, but it's not in this. Okay. That's where the transform section comes into play. Transform allows you to take multiple values and do all kinds of nice, nifty things with it, and then generate a value that actually goes to the server. Okay. So the way we would do this is metrics. The metric itself. Tags is going to be IAM_name constant memory usage. Okay. And now we're going to define this underscore temp, which is going to be free. I'm just going to name the variable free, which is text / data / this. We'll call it free kbytes. And then another one is going to be used kbytes. Okay, so now we define 2 temporary variables that hold that. Now what we're going to do is transform value.double pipe, and then we open an awk section. And here, what I can do is this. Return use kbytes divided by free kbytes plus use kbytes. What did I do here? I grabbed data from the XML structure into temporary variables, and then I ran a transform on them. And I said, what I want to do is generate a double value that is calculated through awk code. And the awk code knows to replace these with the values that have come from the temp. Notice this pipe. This pipe is important because this pipe tells it, okay, now I'm going to have a big section here. The pipe is part of the syntax saying this field is now going to be multi-line. Okay, and these curly brackets show it when it starts and when it ends. Notice that they start in an indentation from the underscore value. If they don't, it won't be able to see them because YAML is going to think I'm now on the next section. Okay, so this is a YAML feature, but this little awk thing inside is a feature within our parsers.
Is spacing important for pipe?
Yes. Yeah. Okay. Well, I haven't tried it without, but YAML tends to be sensitive to stuff, so maybe I don't know. We can test. One space. Okay. It's one space. Yeah. We did one space. It will work with more. I don't remember if it works with no space or not. Okay. Can try. But so you're going to see a lot of transform actually. As you start digging into XML and JSON parsers, you're going to see a massive amount of transform because every time the knowledge experts like Patrick, Arya, et cetera, every time they needed to hack something like this, they use transform. You get creative very quickly with these things. And there are all kinds of interesting things you learn along the way as you're writing this, but it's very, very powerful. Yep.
Does the transform default to a single decimal place, or can you get
as much as you want? Yeah, as much as you want. I think awk has a limit, but I don't think we got there. Okay.
I think Jonathan just wrote something. I don't know if it was a transform, but for checkpoint and bandwidth. So he added 2 metrics essentially together. I don't know if you saw that one. Yeah.
Jonathan, what, in an awk parser or in?
It would have been an awk parser.
Oh, yeah.
But John, who's doing for PanOS, might be doing it for.
Yeah, he would
XML.
probably need the transform on XML, most probably, because if he needs to divide one value by the other, he would probably need the transform.
I think they're adding.
Or adding.
Yeah. Okay.
Yeah, if you're trying to do any calculation on any of these values, you're gonna need to do it. Now you can do this for non-numeric stuff too. Like I could do a transform complex, and then do something like this, name pipe, and then this will do even print. Actually, is it return or is it print? Now I'm confused. Sorry, I haven't written in a while. It's print, it's not return. Sorry, print. It's print. No. Okay. So if we think about the levels of the parsers, the first thing you want to master is the path language, JSON path or XML path, and using those online calculators and getting them kind of nailed down. Then you want to work on the metrics. You want to start with the double metrics and then complex arrays, and then tackle the transform. Those are the stages I would go through to kind of keep moving the challenge level up and up and up, and not directly jumping into something too complicated.
Does that make sense Bacillus, James?
Yes, it's clear. It needs practice a lot, but it's clear.
I know.
Yeah.
It's a good thing we're recording, right? Yeah, it'll come.
Yeah.
So.
It needs a lot of practice. Again, I mean, we have had experience. First of all, it took me a while to pick this up. I can tell you that. I would go to the engineering guys every single day asking them questions, and they'd be like, "What didn't you get? It's this." Like, okay. And then I ran for a few days. I got comfortable with it, and then we trained a few guys on it. And for them also, it took a while. Like some things were not 100% intuitive. Once you get used to it, all of a sudden you're very powerful and you can write these scripts really fast. And you see that you can really achieve a lot with them. Because trying to do anything similar in awk would be a nightmare. Just awk is not built for this. So it's great, but yes, you need to have stamina and go through, a few rounds of these before you get used to it. Any questions? Anything you guys want to add?
Yeah.
Yes.
Okay, great. Thank you very much, everybody. Have a good night or day or wherever you are.
Yeah. It's pretty late there.
Yeah.
Yes.
Athens, Greece. I don't know.
Yes.
Yeah.
Super hot there still.
Almost midnight here.
Thanks. Anyways. All right.
Thank
Thank
you.
you.
Okay.
Appreciate it.
Goodbye. Bye. Bye.
Bye.
Have a nice day. Bye.